Let's be real. Whether you absolutely love math or it's always felt a bit, well, like a foreign language to you, numerical systems are literally the foundational building blocks of the universe. So in this explainer, we're going to break down exactly what types of numbers we use every single day, where they actually come from, and how they shape our reality. Okay, let's dive into this. We've got 5 sections to get through today. First up, the origins of numbers. Second, the number menu. Third, rational versus irrational. Fourth, the imaginary realm. And finally, Section 5, test your skills.
All right, Section 1, the origins of numbers.
You know, before we even think about calculators or complex equations, humanity was desperately trying to quantify and measure the world around them. And I mean a long time ago, like 22,000 years ago. Early humans were already actively doing math. Deep in the Congo Basin, archaeologists discovered a bone dating back 22 millennia, and it's covered in these deliberately carved notches used for simple tallies. So humanity has possessed this urge to count for a very, very long time.
But here's the thing, it wasn't just basic counting. This ancient Congo Basin bone actually features a list of prime numbers between 10 and 20. I mean, it completely blows my mind that tens of thousands of years ago, early humans were already recognizing these complex mathematical patterns. It just goes to show that mathematical curiosity is practically baked right into our DNA. Now, fast forward to today. The crazy thing is, the infinite complexities of modern mathematics still boil down to a surprisingly small set of tools. Specifically, just 10 fundamental digits. We call this modern mathematical language the Hindu-Arabic system. It's a decimal system, which simply means it's entirely based on the number 10. And through the frankly brilliant invention of place value, we can construct literally any number in the universe using just the digits 0 through 9. It is just wonderfully efficient.
Moving right along, Section 2, the number menu.
Now, to fluently speak the language of math, we've got to meet our cast of characters. Let's walk through our foundational whole numbers. First up, natural numbers. These are your basic counting numbers from 1 to infinity, usually skipping 0. Then we have odd numbers, which you can't divide evenly by 2, and even numbers, which you can. Simple enough, right? Then we step up to integers. This category expands our toolkit by including all positive whole numbers, all negative whole numbers, and crucially, 0.
Now, what's really interesting here is when we start defining numbers by their properties and relationships. We have prime numbers, which only have 2 factors, the number 1 and themselves. Next are square numbers, which are simply the result of an integer multiplied by itself, like, say, 4 times 4, giving us 16. And of course, when we need to express something that isn't whole, we rely on fractions to show a part of a whole, and decimals, which use our base 10 place value to represent those fractions.
Just a really quick practical tip before we move on, because mathematical terminology can sometimes trip people up unnecessarily. When a math problem asks for the product of 2 numbers, it's simply asking you to multiply them together. That's it. So the product of 3 and 4 is 12. Easy to remember and super helpful to keep in your back pocket.
Okay, Section 3, rational versus irrational.
So we're now going to take this overarching universe of everyday numbers and divide them into 2 very distinct personalities. But first, let's establish that all the numbers we've discussed so far, and basically all the numbers you use in standard math, are officially known as real numbers. Everything from basic integers to complex fractions and decimals lives under this real number umbrella. But inside this umbrella, well, things get divided. And these 2 subgroups have a stark contrast. On one side, we have rational numbers. These are the well-behaved members of the family. They can be cleanly written as fractions. Even when they're decimals, they either terminate neatly, like 0.75, or they recur in a very predictable pattern. On the flip side, we have the messy, irrational numbers. These guys absolutely refuse to be written as simple fractions, and their decimal forms go on forever without any repeating pattern whatsoever. Think of it this way. A well-behaved, recurring rational number is kind of like a neatly coiled slinky, looping perfectly around and around in a reliable pattern. An irrational number, however, it's chaotic. Its decimal string unravels endlessly outward in a totally random string of digits that never loops back on a pattern. It just keeps going. And actually, some of the most famous numbers in the world are these messy, irrational ones. Pi is a perfect example. It famously goes on forever without a repeating pattern. Others include the square root of 2, or the square root of literally any number that isn't a perfect square, like the square root of 12. They are infinitely chaotic. All right, Section 4, the imaginary realm.
Now, I just want to give you a very brief tease into the advanced mathematics that exists completely beyond our everyday real numbers. While basically everything you interact with daily is a real number, there's an entire category of not-so-real numbers known as imaginary numbers. The classic example is taking the square root of a negative number, like the square root of -1. While you definitely won't need this for basic everyday math, it's this fascinating territory that becomes incredibly important later on in advanced physics and engineering. So yeah, the mathematical universe is way bigger than what we can easily count. Finally, Section 5, test your skills. All right, it's time to put all this newly acquired mathematical vocabulary to a practical field test. Consider this mixed set of data right here. -4, -1, 0, 1/2, 0.75, 3, 4, 6, 11, 16, 19, and 25. I want you to mentally prepare to categorize these characters into the number menu we just learned about.
First challenge. Scan that list. Can you pinpoint the prime numbers? Remember the hint. These are numbers greater than 1 that can only be divided by the number 1 and themselves. Take a quick second to look. Okay, if you guessed 3, 11, and 19, you are absolutely correct. These are the lone wolves of the number line. Their only factors are 1 and the number itself. Let's do one final challenge, and we'll make it a double. Scanning that exact same list, can you find the square numbers? And then, can you pick out the negative integers? All right, let's see how you did. The square numbers, which, remember, are integers multiplied by themselves, are 4, 16, and 25. And the negative integers, the whole numbers falling below 0 on the number line, are -4 and -1. If you successfully navigated that, you've pretty much mastered the number zoo. So the crucial takeaway here is this. We've gone from ancient humans making scratches on a bone in the Congo Basin to a beautifully structured system of rational, irrational, and even imaginary numbers. It really begs the question, how did a system invented simply to tally notches evolve to possess the exact language needed to explain the infinite complexities of the cosmos? It's a remarkable thought to chew on, and it perfectly sets the stage for exploring even more advanced mathematics in the future. Thanks for joining me on this explainer, and keep exploring.